All right, so if you guys could go to your note sheet and down towards the bottom when we were doing this vertex form stuff, if you continue to scroll down past there, the next section is solving other types of equations algebraically. Okay, so I'll give you a second to find that. But there's no graphic involved with these. I mean, you can solve something by graphic, but we're going to do it algebraically as it says. So we basically want to solve them for x. And there's a bunch of different types of problems that we will be doing. So let's just jump in and start with problem A here. So we want to solve this for x. So in this case, I look at this and say, I want to get everything on one side, so I'm going to move the 48x squared over to the left. So I have 3x to the fourth minus 48x squared is equal to 0. The reason I want to get it on one side is so that I could factor and then use the zero product property. So I can factor, I know I could factor x squared out, but I think I could actually factor a 3 out also. So I can factor 3x squared out of that. And so when I take 3x squared out of 3x to the fourth, I'm left with x squared. And when I take 3x squared out of 48x squared, I'm left with negative 16. So I'm just factoring I took out a GCF. All right, if I'm missing something or if I write out a step and you don't know where it's at or how I got that, please make sure you ask. I'm just going to continue to factor this though. I see that I have a difference of squares here. So I have 3x squared, and then that's going to factor into x minus 4 times x plus 4. And now it is fully factored. So I can use the zero product property by setting all parts equal to 0. And so my answers, I'll write it out, but my answers are going to be 0, 4, and negative 4. But just to show you what we do 3x squared equals 0. So if I divide by 3, 0 divided by 3 is 0. Take the square root of both sides. So I get x equals 0. That's one answer. Then I would do x minus 4 equals 0. So x equals 4. That's another answer. And my third answer, I have x plus 4 equals 0. And so x equals negative 4. So I get 3 possible answers. So the idea is get everything on one side, factor, use the zero product property. All right, part B. That looks hard to factor the way it is, and I think it is hard because we have a GCF. So it looks like I can take x out, but I can also take 6 goes into 6 and 54, but not 27, but I could take a 3x out. So I could write that as 3x times 2x squared minus 9x minus 18 is equal to 0. Okay, so I factor the 3x out of that. Now I have to factor this thing. So let's see, I have 2x and x. And if I did, let's see, 6 and 3, I think that's going to work if I have negative 12x and positive 3x. So it looks like it factors into 2x plus 3 times x minus 6. So now again, using the zero product property, My answers are going to be 0, -3/2. If I set that equals 0, I'll get -3/2 and +6. Okay, so without writing those out, I get x equals 0, -3/2, and +6. Does anybody have any questions how I got any of those 3 answers? You should put a 0 in your answer. So, and I'm glad you asked that. Because when you look at like the first one, and I actually saw a couple people doing this, like dividing both sides by x squared to get rid of it. We can't do that because you would be losing that value. Think about if you plug 0 in for x, that first one, that's a true statement. Okay, so 0 is a solution. If you plug a 0 in for x into part B, you'll get 0 minus 0 minus 0. That does equal 0. You would be losing that solution. Okay, so we have to factor out that x and not just divide it out. The point is you never want to divide by a variable to lose that variable, because then you would be losing a solution. All right, part C. All right, this one we have an x to the 4th. Now I'm going to do this 2 ways. Okay, first, don't be freaked out by the x to the 4th. If this was x squared minus 3x plus 2, you guys would probably think it's an easy problem. So what I'm going to do is I'm going to do a substitution. I'm going to say, I'm going to let, I'll call it u equals x squared. Okay, I'm making a substitution where u is equal to x squared. So now what if u is x squared, that left part would be u squared minus 3u plus 2. Because remember, if u is x squared, then u squared is x squared squared, which is x to the 4th. Okay, so I kind of replaced x squared with a single variable, which I then could solve for. If I factor this, I could factor it for u to solve it for u. So I would get u minus 2, u minus 1. And so my answers for u would be u equals 2 and u equals 1. But there's I'm not done yet though, because the question didn't ask me to solve for u, it asked me to solve for x. So I now then have to go back and substitute those in again to solve for x. I'm going to get 2 equations. I'm going to get 2 equals x squared, which I then could solve for x. And the second equation would be 1 equals x squared. Yes. Yeah, so now we have to square root it to get x by itself, exactly. And when we square root that, don't forget it's going to be plus or minus. So x is going to be plus or minus the square root of 2. And x is going to be plus or minus the square root of 1, which is just 1. All right, any questions on that? So if you get that, go with it and do that. I'm going to show you a totally different way to do it, which would be perfectly fine also. That a different way would be, if you're good at factoring, we could just factor that right away. But when we factor it, I can't just have x and x as my first 2 terms. It's going to have to be x squared and x squared. And so that factors into x squared minus 2 times x squared minus 1. So this would be a different way to do it. You don't have to do both, of course. But notice what we get there, because if we were to FOIL this out, x squared times x squared, that gives us our x to the 4th. In our middle terms, I would have negative x squared and minus 2 more x squared gives us our negative 3x squared in the middle. So it works factoring that way. Which we then could use the zero product property if we set x squared minus 2 equal to 0. And solve that. So x squared equals 2, or x equals plus or minus the square root of 2. That, of course, is the same answer we got on the other side. And then I could set the other part, the x squared minus 1 equal to 0. And that's going to give me my plus or minus 1. So you can do it one way or the other, but of course you don't have to do both ways. Okay, any questions on the first row? All right, I'm gonna do the next one. I'm gonna do a substitution method, but you don't have to. So the substitution method was this, and I'm gonna apply that to this problem. You can do just factor it right away if that works for you also. But I'm gonna again let u equal x squared. And so I'm gonna write that as u squared minus 8u minus 9 equals 0. And then solve that for u and resubstitute back in. Sorry. So when I solve that for u, I have to factor it. So I have u minus 9, u plus 1. And so u equals 9 or negative 1. But now we have to go back and solve for x. So my first equation will be 9 equals x squared. My second equation will be negative 1 equals x squared. Then I'll solve both of those for x. On the left side, when I take the square root of both sides, I get x equals plus or minus 3, because it's square root of 9. And on the right side, I get x equals plus or minus the square root of negative 1, which of course is I. So we have 4 solutions: positive 3, negative 3, positive I, and negative I. All right, part E. We're going to have to factor this. This is testing our factoring skills here. So,
Why is it positive or negative 9?
for this one?
Yeah.
So here I'm taking the square root of both sides. And so I get the square root of negative 1 plus or minus the square root of negative 1 is equal to x. I took the square root plus or minus the square root of that. Hear that?
So then you do that with the result. The square root of 9, you have positive or negative 3.
Correct. And when you do the square root, positive or negative, the square root of negative 1 is plus or minus. So you're missing a plus or minus. So it'd be plus or minus the square root of negative 1, and the square root of negative 1 is I.
I don't know, that's kind of weird.
Well, we're taking, again, we have, so we have -1 is equal to the square root of x. Oops, I'm sorry, -1 is equal to x squared, sorry. So we're taking the square root of both sides, right? So we're doing this and that. And so when we do that, on the left side, we get plus or minus the square root of -1. And on the right side,
Oh, because if there
Okay.
is such a thing as -1.
there is a negative I, yeah. And so we get plus or minus I on the left side. There, you got it now?
Yeah.
Okay. All right, good. Let's factor part E here. So when we have 4 terms, we can do a grouping factor by grouping the first 2 together and the next 2 together and taking out a GCF. So when I take out a common factor of the first 2, I get x squared times x minus 3 Okay, so I took an x squared out of those first 2 terms. And for the next one, I'm going to take a 9 out of there because that's my GCF. I get 9 times x minus 3. And now, because I have x minus 3 and x minus 3, I can factor those out front. And this becomes x minus 3 times my leftover stuff, which is x squared plus 9. Yes? No, because you're just factoring it out. So it's kind of like if you had x squared times y plus 9 times y, you would take the y out front like that, like you don't square the y in this case. So we're thinking of this x minus 3 as all one term. You don't square the x minus 3. Okay, good question. That's a really common thing that happens. Yes.
Wait, so when you put them together, it's just like
Yeah, well, just think if you factor this, right? I mean, if you distribute it, if we did x minus 3 times x squared, we would get this. And if we did x minus 3 times 9, we would get this. Okay, so we're really factoring out a GCF. It's just different because it's a big chunk. It's not just a letter or a number. Yeah.
Wouldn't you just have 9x squared plus the quantity of x minus 3? Would that be the same thing?
You could do 9 plus x squared, but not 9 times x squared. Or you could do 9 plus x squared times that. That would work.
Oh, right.
Yeah. All right, so we've got 0 product properties. So I'm going to set x minus 3 equal to 0. So one answer is that x equals 3. And I have x squared plus 9 is equal to 0. And I have to solve that guy. So when I do that, x comes out to be plus or minus the square root of -9, which is plus or minus 3i. All right, next one, F. It's 4 terms again. So I'm going to factor it the same way by grouping. I'm going to group the first 2 together and then group the next 2 together and take out GCFs. So when I factor the first 2 together, I take out a 2x squared. I'm left with x minus 6. I'm sorry, x minus 3. Now for my second part, if I take out a -8, I'm also left with x minus 3. All right, and so now using a similar method, I'm going to factor that x minus 3 out front, so I get x minus 3 times 2x squared minus 8. And again, use the zero product property from here once it's all factored. So I set x minus 3 equal to 0. And 2x squared minus 8 equal to 0, and solve both of those. So on the right side, I get 2x squared minus 8 equals 0. So 2x squared equals 8, so x squared equals 4. My answers for x are plus or minus 2 and 3. Yes. Yes, when you're taking the square root. Yep, you said, asked if it's plus or minus every time you take the square root. Yes. All right, I am going to do 2 more. Are there any questions on any of those that you'd like me to explain again? All right, let's do here. We're going to do part A, example 2. This is different. We have a fractional exponent here. It's an equation, so it's similar in that respect. But we're not going to factor. We have to get rid of this 2/3 power. So to get rid of the 2/3 power, what we can do is take both sides to the 3/2 power. Okay, just flip 2/3 over. So you're taking both sides to the 3/2 power. Yes. The reason it affects the left side, or the only way it affects the left side is, remember, a power to a power, we would multiply 2/3 times 3/2, which is 1. So the left side just becomes x plus 1. So it doesn't affect the stuff inside of the parentheses, but it gets rid of the fractional exponents. On the right side, remember the bottom is the root and the top is the power. So that is the square root of 4 to the 3rd power. What's the square root of 4? 2, and 2 to the 3rd is 8, right? Square root of 4, we also wouldn't want to write as -2. And -2 to the 3rd is -8. So we actually have 2 equations. Because when we take the square root of 4, we get 2, and that gives us this equation, 2. And when we take the square root of 4, we get -2, and -2 to the 3rd is our -8. That gives us the second equation. Okay, so it goes back to the idea of taking the plus and minus when we take the square root. Yes?
Can you just do the power?
Yes, you could. Yeah, good question. So he said, could you do the power first? So 4 to the 3rd power is 64, and then the square root of 64 is plus or minus 8. That would work also. Yeah. Yes. Yeah. So we did to get the 8 and -8, I'm doing this part right here. So the bottom number is the root, so I'm doing the square root of 4. And the top number is the power, so that's to the 3rd power. The problem is the square root of 4 has two possibilities. It's +2, or it's -2. So if you take +2 to the 3rd, that's where the 8 comes from. And if you do the -2 to the 3rd, that's where the -8 comes from. Yes,
Can you do the power first and then square root it?
you can, yes, and you still get 8 and -8, yep. You sometimes run into a little trouble there when you get really big numbers when you use the power, but this one's certainly doable, yeah.
So you get 2 different answers because of plus and minus, right?
Because of the plus and minus, exactly. And so our two answers are then x equals 7, right? 8 minus 1 and -9. I will leave it up, yeah. All right, maybe that's enough for today. We kind of threw enough at you for one day. Are there any other questions? You guys had great questions today. Anything else while it's up there?